Early today, as we mentioned, Space Station Commander Kevin Ford was at work in the Destiny Laboratory. He powered up the Robonaut experiment and set up the cameras so it could record Robonaut's actions during ground-commanded activities. That's got started on board the station last year. This experiment is ongoing. Right now, Ford is disassembling Robonaut and preparing to stow it before its next work session. In order to learn more about this robot and its work on the station, I'm joined here in the flight control room this morning by Dr. Ron Diffler. He is the Robonaut project lead based here at the Johnson Space Center in Houston. Good morning. Thanks for being here.
Well, thank you, Pat.
How and when did you become involved in the Robonaut project?
I started in the late 1990s. My first job was actually working on the design of the forearm and the hand. After we completed the design of it, I worked quite a bit on the control system. Later on in the project, I became the hand subsystem lead, then moved on to become first the deputy project lead, then the project lead in the early 2000s.
When did the design really get started?
Well, that was for the first Robonaut, Robonaut 1, which is not in space. It was a prototype for the ground. We started working on Robonaut 2 in 2007. That was the beginning of our partnership with General Motors.
And just to give a sense of how long it sometimes takes for these things to develop, how has a partnership with General Motors helped in the development?
Oh, it's been an excellent partnership. It's allowed us to combine our resources with General Motors to build a better Robonaut system, the one that we have in space, than we could have done independently. By pooling our resources, we took advantage of the skills in both areas and allowed us to produce a system that's been doing very well on orbit.
How would you describe the overall goals of this project? What are you trying to accomplish with the Robonaut in space?
Well, our goal is to provide another tool for the space station community. As my boss likes to say, another pair of hands to help out on board the space station. We have the robot up there right now as a fixed system on a stanchion, just an upper body. And we are going through a variety of tests to verify that it can perform the way we expect it to do many of the tasks that it was able to do on the ground. This is all a precursor for later having the robot go mobile and helping inside the space station.
But how has it gone so far?
Oh, it's gone very well. We, as you mentioned, it was sent up there in 2011. And actually, 2011. We've been working with it now on space station for a little more than a year. We went through our checkout, which went very well. We've completed free space tasks. We've done our first interaction with the crew, human-robot interaction, which was a big thing for us. We've been working on the task panel, some of which you saw that activity today. We've also had a chance to work with our first tool on station, actually an airflow meter. With that device, we were able to send back data that normally isn't received on the ground, which was a great thing to help out providing even more information back to the crew, back to the support personnel that are helping the crew perform their tasks in space.
What was the task with the airflow meter? What did Robonaut have to actually do?
Well, normally, a few times a year, the crew uses a wand and a meter, and they measure the airflow coming out through the vents in various parts of the space station. Actually, a perfect job for a robot. Nothing can hold something still better than a robot, as you might expect. In this case, we had the robot hold the wand and the meter, and what was unique about this particular situation is that normally the crew averages out the values they see on the meter and then sends down a few numbers to the ground. Here, the people on the ground were able to look through the robot's eyes using the robot's camera system and see real-time data coming through the air vents. And that was really cool because that was data they had never seen before.
We've seen video over today and yesterday of the view from Robonaut's eye. Is the point of that to allow the ground to see what Robonaut sees, or is it registering data that's recorded itself?
Well, there are actually multiple camera systems. The ones we're seeing on the ground right now are the ones we would use when a person directly controls the robot. That can be done a couple different ways. On the ground, we are performing experiments, and the people on the ground can see the robot perform their tasks with real-time data. That, of course, allows for a more expedited task. Also, when the crew will in the future don what we call teleoperation gear. They wear a variety of gloves and other sensors, and as they move around, the robot will track their position. When they're doing that, they'll be able to put on a helmet-like device, and they'll see through those same robot eyes so they can have a good perspective as they're performing tasks, basically mated to the robot.
They're controlling the robot's actions with their own actions.
That's correct.
That sounds like that would have application for using it anywhere in the station or outside the station?
Actually, that's the biggest value will be when we have the crew person controlling the robot directly when the robot is on the outside of the station, which is something we're planning in the future. We'll do experiments inside the station where we'll practice this technique where the human and the crew person and the robot are right near each other as we develop that and be sure that it works well in the zero-G environment.
The development is being done in small steps. It's because you said you've been working on it for years.
A little
Yeah.
more than a year, and
Yeah.
we've been increasing the difficulty of the tasks, essentially. We've been adding to the capability of the robot over time by trying out different subsystems. Initially, we were just controlling it and having it go to predefined positions. Today's experiments, as a matter of fact, involve the use of machine vision. We're using the robot's other set of cameras, machine vision cameras, to find locations where objects are, and the robot drives its hand to those locations. We're doing initial work with that right now to calibrate and verify that the vision system is working properly and adjust it accordingly. Later, we'll incorporate that machine vision technology, and the robot will do tasks in a more automated fashion using that sensor information coming from the cameras.
And I think that sounds like the Robonaut would be able to be a lot more useful to the crew if it could perform automated tasks. They'd be given tasks and allowed to go about its business.
Absolutely. We see a progression. Right now, we're controlling many of the motions in a very definitive manner, controlling each part of the task very precisely. We later expect to go to a more semi-autonomous mode, where the ground personnel will be doing more supervision, and then as time goes on and we gain more confidence in the system and everything is proven out, we go to even more autonomous type mode, where there'd be less supervision from the ground.
Why is the Robonaut only an upper body right now?
Well, when we first started our work with General Motors, our focus was on manipulation, the ability to perform tasks that currently only humans can perform. So we started working with that part of the body that's involved in those types of tasks, the upper body, arms, hands, a head, to have sensor systems in it so you can see what you're doing. Now we're looking towards the future where we'll need to go mobile. If we're going to be helping the crew both inside and outside the space station, we need that mobility. We're working on a pair of what we call climbing legs, which we will add to the upper body of the robot and allow it to move throughout the inside of the station initially, and then eventually outside the station, and perform the kinds of tasks that we're testing out capabilities for right now on our task board and with the tools I mentioned earlier.
It occurred to me that if it had legs, you could probably make it walk. You just couldn't keep it on the ground. Couldn't keep it down on the floor of the station.
And that's why we call these climbing legs, because our protocol will be that we will move from one fixed location to another. The robot will always have one leg in contact so that it'll be grounded as it's performing its task.
Looking ahead, what is the next step or the next couple of steps in the development and the testing?
Well, we're continuing to work with our task board, integrating first our vision data, some of which we're working on today. We'll be adding more force information to performing our tasks. Just like a human, we use a variety of sensor information to perform our tasks, vision, force data, and we're testing out those capabilities on the robot. We'll be adding more tools to our repertoire. We hope to be using a tether hook. It's just our early practice when we go EVA. And then, of course, we'll be sending up the legs and then a battery backpack so we can be untethered and start moving in the station. We expect to send those up in the later part of 2013 and start performing our first tests in early 2014 of the robot, checking out its lower body and then starting to move throughout the space station.
Awkward if it's becoming self-aware and discovering its own self?
We'll be working with it to check out to be sure that all the new parts we're sending up work well. But right now, its consciousness is pretty much limited to what we tell it to do.
Have you given any thought to giving it a voice?
We have an as a matter of fact, when you're wearing the teleoperation gear, which I mentioned earlier, and you're wearing the helmet, you'll also have a microphone. This allows the crew person, to command the robot to change modes. For example, if they're performing a task and they want to rest, they can tell the robot to freeze its limbs, and the robot's limbs will start moving, and the crew person can stop. So we do have a voice interaction system integrated, but we only use it right now when we're doing teleoperation.
So the look ahead, then, it may be this time next year, or roughly, where we could see it really interacting with the crew members and performing tasks.
We'll definitely see it starting to take its first steps in that climbing process I mentioned.
Ron, it's fascinating and it's great to watch, and I really appreciate your helping get us up to speed on what's going on with it. Thank you very much.
My pleasure.
Dr. Ron Diffler is the Robonaut project lead based here at the Johnson Space Center in Houston.